This is our section on graphing trigonometric functions, and we're going to look at a lot of variations on this. We'll start off with the basic one, y equals cosine of x. And I'll make my vertical axis, horizontal axis. I know that the general period for cosine is 2 pi, and I also know that cosine is going to start at the maximum, it's going to end at the minimum, and so I have my vertical axis set up. Halfway through the first period is an x value of pi. The quarter point has an x value of pi over 2. The 3/4 point is 3 pi over 2. So there's my good details for the first period. For the second period, it's going to end at 4 pi, and then I'll just put points at the quarter points and 3/4 points. Next, again, I know it's cosine starting at the maximum. At the end, it'll be up at the maximum again. Halfway through, it's at the minimum. And then in between, we're right in the middle. I'll put those same points for the second period. And now you can draw the smooth curve that connects all those points together. And there are 2 periods of the cosine curve. Cosine is just like the sine curve. It's just a translation of it, actually. So if we were to look at y equals the sine of x, a lot of it is going to be the same. However, we use red for this one. Sine starts at the midline. It's going to end the period at the midline. Halfway through at the midline, sine goes up first, and then it goes down. And then for the second period, it's going to end in the midline again. Halfway through, it's at the midline. The quarter point is at the maximum, 3/4 minimum. And so then I could graph this one. And there is our sine curve. You can see how the blue and the red are very similar to each other. They have the same period, the same amplitude, and the only difference is where they're starting and where they're ending at. Now, depending on any other kind of variations, the graphs will change. So let's go ahead and write out this equation. Y equals 3 times the cosine of x. Our goal is to graph this one. The only change is the amplitude is now going to be 3. So instead of a maximum height of 1, it's going to have a maximum height of 3 and a minimum height of -3. Otherwise, this graph is exactly the same. The first period will end at 2 pi, the second period will end at 4 pi, and it's going to start at the maximum, end at the maximum, halfway through the minimum, the quarter point and 3/4 points on the midline. So there's our first period. We could fill in the details with those x values, but that's not going to change from our original one of the parent function. Same thing for that second period, and this is what it's going to generally look like. Next, we'll look at y equals -4 sine of x. This has 2 things going on. First of all, the amplitude is going to be 4 this time because the absolute value of a number in front of us gives us our amplitude. And what the negative is doing is it's reflecting the whole graph across the horizontal axis, which in this case is the x-axis, but sometimes that axis will be moved with translation up or down. This is sine instead of cosine. I know the period is still going to be 2 pi. The second period will end at 4 pi. And the amplitude is 4, so maximum height of 4, minimum height of -4. And we can mark the starting and ending points. It's still sine, so it's starting and ending in the middle. Halfway through, it's going to be in the middle. But here's where it's different for sine. Instead of going up, it's going to go down. So the quarter point is going to be at the minimum, the 3/4 point at the maximum. And we can fill out those same points again for the second period, and then draw in our smooth curve that connects all those points together. And there's 2 periods of this one. Now, if I were going to submit this as a formal problem, I'd fill in the x values for the first period to get more precise, but again, this doesn't change from the first one we looked at. Next graph has a vertical shift of up 3, it's the 3 plus sine of x. So as I'm looking to graph this one, the amplitude is still 1 because that's the coefficient right in front of sine, but instead of using this x-axis as our midline, we're going to shift up by 3. I'll draw a dotted line here to show that this is the horizontal axis that the graph is going to be kind of swirling around. With the amplitude of 1 means the maximum height is 4, the minimum height is 2. The period doesn't change, so the first period is going to end at 2 pi, second period is still going to end at 4 pi. I'll put the significant points on there. This is a sine curve, so it's going to start, end, and halfway through be right on that midline. It's going to go up at the quarter point, down to the minimum at the 3/4 point. You can put in those same values for the second period, and here is our curve for 3 plus the sine of x. Now on this same graph, let's go ahead and look at y equals 4 minus the cosine of x. So I've got a couple of things going on here. Actually, let's change it to negative 4 minus the cosine of x. So what that's going to do is shift the whole graph down by 4. So our new midline is at y equals negative 4. The negative in front of this one means that the amplitude is still 1, but it's going to reflect. So now when I am setting up the rest of this x-axis, the maximum height is negative 3, the minimum height is negative 5, negative 4 is there in the middle. And it's a cosine. Cosine normally starts at the maximum, but because of this negative, it's going to start at the minimum. The end of the period is the minimum. The halfway point, it's maximum, and I can fill in those quarter points. Do the same thing for our second period. And here is our cosine curve for negative 4 minus the cosine of x. Look at a composite of different transformations this time. First of all, with the negative 2, the whole graph is going to go down 2. With the 3 out front, we know the amplitude is 3, so I can set up this vertical axis. Negative 2, this is going to be our line of equilibrium, or our midline. Amplitude is 3, so from there I'm going to go up 1, 2, 3. So positive 1 is the maximum. Go down 1, 2, 3. So negative 5 is the minimum. So with this information, I can set up that vertical axis. Nothing changes on the horizontal axis. The period still is the same. It didn't shift left or right at all. And it is a cosine. Cosine starts at the maximum, ends at the maximum, halfway through minimum. Put the quarter points in there. Second period, we have the same thing going on. And then we can draw in that smooth curve that connects all those points together. And kind of change to the graph. There's no number added out front. There's no number multiplied by this. There's no negative in there. So nothing in the vertical components are going to change. However, we have the 4x in there, which is going to make the period go 4 times faster. It's going to cycle through those values 4 times faster, which in essence is shortening the period. The period is normally 2 pi. However, we're going to take 2 pi divided by this value right in front of the x. And if we simplify that, we get pi over 2. So then in graphing this one, the amplitude is 1. So the maximum and minimum heights are 1 and negative 1. The period is pi over 2, which means the second period is going to end at pi. Half of pi over 2 would be pi over 4. Half of pi over 4 is pi over 8. So I'm setting up these x values. Pi over 8, 2 pi over 8. That makes this 3 pi over 8, 4 pi over 8. And then I don't need to get all the details for the second one. So set up the vertical axis, set up the horizontal axis. It is a cosine, so it starts and ends at the maximum, halfway through minimum with those quarter points. Same thing on the second period, and we have this nice curve that connects it all together. Period change, and that's the only variation on this one. So the period for this graph is 2 pi over 1/2, and if you simplify that, you get 4 pi. So 4 pi is where the first period is going to end. Double that, 8 pi is where the second period is going to end. Like before, we have an amplitude of 1, and there's no vertical shifts in it. Half of 4 pi is 2 pi. Half of that is pi. 1 pi, 2 pi, 3 pi, 4 pi, and then let's put values or hash marks where those values would be. It is a sine curve, so it's going to start, end, halfway through beyond that midline. It would go up and down. Second period, we're going to have those same values repeated, and then our curve is going to go through those points. Now look at a phase shift. The equation is y equals cosine of x minus pi over 2. The minus pi over 2 is inside of the function, which means that this one is going to be shifting right by pi over 2. And I'll write that down here. However, the next kind of problem we're going to look at has a period change and a phase shift. And I'll show you how we can deal with those really in a simpler way. So what we know is that the graph is going to be starting at pi over 2. The period didn't change because there's no number in front of this x. So if I add 2 pi onto that, that would give us 5 pi over 2. Add 2 pi more, and that means it would be at 9 pi over 2 where the second period ends. Just to make sure this scale looks a little bit better, we'll move that further to the left. Okay, so then 1 pi over 2, 5 pi over 2, halfway between would be 3 pi over 2. We have 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi, 5 pi over 2, and then we'll fill in the rest of these points. Now it's just like all the other graphs we've done. We need to set up our vertical axis, maximum, minimum heights. There weren't any vertical shifts in this one. As far as the values, it is cosine, so maximum here, maximum there, halfway through minimum with the quarter points. Do erase just this little straight mark in there. Nope. See if I can correct my mistake here and realize that I put that at the wrong point. So it happens sometimes, cut my mistake. And then the second period, maximum, minimum, quarter points. And then we can draw in the curve that connects them all together. Equals cosine of 3x minus pi. The period in this one is 2 pi over 3. No vertical shifts, amplitude is still 1, there's no reflections here. The shift is not right by pi, even though it kind of looks like it. If we factored out the 3, divide this by 3, divide that by 3, we see it's actually shifting right by pi over 3. What I like to do instead, though, is take that expression on the inside. We're going to set it equal to 0, and then solve for x. So x equals pi over 3, we get the same result. That's where our first period is going to begin. Normally the first period ends at 2 pi, so I'm going to take that same expression again and now set it equal to 2 pi. So add pi to both sides, divide by 3, and now I see my first period is ending at pi. And that makes sense because the period is 2 pi over 3. If we add that on to our starting point, we should be ending right there. And if I wanted to, I could add 2 pi over 3 onto this one, or use the same process again, now set it equal to 4 pi, because that's normally where the second period would end. 3x is equal to 5 pi, so x equals 5 pi over 3. There's no other changes on this one, so as far as the vertical axes go, I can set that up very easily. Start at pi over 3, the first period ends at pi, second period ends at 5 pi over 3, and I can draw my points for sine. Last problem with a lot of variations on it, and I'll even make one more small variation. Let's make it 4 minus 2 times the sine of 2x minus pi. Lots of things going on. I'm going to make a list of them. Vertical changes. This whole graph is going to shift up by 4. The amplitude is 2. With that negative, it's going to reflect across the horizontal axis, which because it shifted up by 4, it's not just reflecting across the x-axis. If we factor the 2 out of this, we see that the period is going to change. There's going to be a phase shift as well. 2x minus pi equals 0, so x equals pi over 2. That's where our first period is going to begin. And the period is equal to 2 pi over 2, which is pi. So if we add pi onto that, we'll get where the first period ends. Add another pi onto that, we'll get where the second period ends. As far as graphing this goes, I know the whole thing is going to be shifting up, so I'm going to leave a lot of space above this initial axis. Up 1, 2, 3, 4. So here is our new line of equilibrium, or midline. The amplitude is 2, so it has a maximum height of 6, a minimum height of 2. Now setting up the x-axis, it's going to start at pi over 2. If we add pi onto that, that would be 3 pi over 2 for the first period, and then add one more pi onto that, and we're at 5 pi over 2 for the end of the second period. The other strategy that I talked about was setting this initial expression on the inside equal to 2 pi, set it equal to 4 pi. We could also figure out where it ends then. Now for the points, it is a sine curve, so it's going to start and end on the midline. Halfway through it's on the midline, but because of this negative, it's not going to go up first, it's going to go down to the minimum, and then it will go up. Same points for the second period, down and then up. To get a little bit more detail in here, halfway between 1 pi over 2 and 3 pi over 2 is 2 pi over 2, which is just pi. Halfway between those would be 2 pi over 2 plus 1 pi over 2, that's 3 pi over 4. So 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, so that keeps working. So I have my nice axes all set up. Draw in the curve that connects it all together. And our graphs aren't going to get any more difficult than this. We have all kinds of variations. We just take them step by step.